Okay, this is the beginning of Unit 10 Test Review 2 worksheet. We are looking at number 26, which is a question that says, a sphere has a volume of 350 cubic inches. Now class, that's just inches cubed, just a different way of saying it. If the size of the sphere is dilated by a scale factor of 2.5, what will be the new volume of the sphere? Well, we know, class, that when you dilate a shape by a scale factor, the volume is going to grow by scale factor cubed. So this is actually a very easy question. We start off with 350 cubic inches, and we're going to multiply that by 2.5 cubed. So let's do that. 350 times, I'll put this in parentheses, you don't have to actually, 2.5, and then I'm going to raise that to the exponent of 3, and we end up with 5468.75. Remember, we're still rounding to 2 decimal places. 5468.75, and that's still inches cubed. So our final answer is 5,468.75 inches cubed. You might ask the question, why do I put that in parentheses? Because I never want to get confused and think this is 5 cubed. Some students will not put it in parentheses and say, oh, 350 times 2 times 5 cubed. So I put it in parentheses to let you know that whole number there, 2.5, is being cubed. Looks like question number 27 is the same kind of problem. A pyramid has a volume of 2.5 million cubic meters, which is the same as just meters cubed. If the size of the pyramid is dilated by a scale factor of 0.8, by the way, class, notice on this first one, 2.5, that's an enlargement. We better have a bigger number than the original. This is a reduction, so we're going to have a smaller number than the original. Okay, by 0.8, what will be the new volume of the pyramid? Well, same process. Take your original volume, 2,500,000, and we're going to multiply that times 0.8 cubed, and let's see what we get. 2,500,000 times 0.8 parenthesis raised to the third power equals 1280000, 1280000 meters cubed. And look at, that's gone down by a lot, by about 50%. By changing the scale, by scaling it by 0.8 or 80%, the volume actually goes down by about half, which is interesting, an interesting mathematical property of volume. So the final answer here is going to be 1,280,000. Notice I don't have to write any decimals because it's an exact number. 280,000 meters cubed. All right, next one. Miss Perry's head. I'm not sure if you know who Miss Perry is, but let's just suppose that her head has a volume of 2,900 centimeters cubed. If we take her head and we make a scale model of it, so a scale model of her head is dilated using a scale factor of 0.25. Class, you should recognize that is a reduction. We're making a smaller head than the original. What will be the volume of the scale model? All right, well, same procedure. Original volume is 2,900 times 0.25 cubed. 2,900 times 0.25 in parentheses, for me at least, raised to the third power. 45.312, we can drop the 2. 45.31. and that's centimeters cubed. Let's go ahead and put that answer in our box. 45.31 centimeters cubed. You can see how much smaller the volume got. It's not 25% of 2900. It's far less than 25% of 2900 because it's reducing by scale factor cubed. All right. Does this work for rectangular prisms? Absolutely. An instant mashed potato box. I wonder if any of you have ever had instant mashed potatoes. If you haven't yet, you'll have it in college if you go to college. Has a volume of 620 cubic centimeters. If the size of the box is dilated by a scale factor of 1.8, that's an enlargement class. What will be the new volume of the box? All right, same thing. Original volume times scale factor cubed will get us our new volume. 620 times, in parentheses, 1.8. Let's raise that to the third power. 3615.84 exactly. 3615.84. Our unit of measure is cubic centimeters. So final answer, 3,615.84 centimeters cubed. Let's go to number 33. Actually, let's skip. Let's go to number 30 in the other column. What is the radius of the largest sphere? The radius of the largest sphere that can be cut out of the cube below. So we've got a cube. We're going to cut off all the extra parts until we're down to a perfect sphere. The question is, what's the largest radius? What's the biggest sphere we can get out of this? Now, class, if you imagine a sphere fitting inside a cube, if the dimensions of the edges of the cube are 12 inches, we know that's also going to be the diameter of the sphere inside, or the distance all the way across. If the diameter, so I'll just write a note here, if the diameter of the sphere is going to be 12 inches, then the radius is going to be 12, and that looks a lot like pi. Let's fix that. It's going to be 12 inches. Then the radius is going to be 12 divided by 2, which is 6 inches. So the biggest circle, the biggest sphere we can fit in this cube has a radius of 6 inches. Let's take a look at the next one. Same kind of problem. What is the radius of the largest sphere that can be cut out of the rectangular prism below? Well, you see, class, if you had a radius, let's kind of draw one in real quick. If you had, let's try and put this in here. If you put a sphere inside of this shape, you've got a lot of extra space on top. Your limiting factor here, what's going to limit the radius, is the smallest dimension, which in this case is 3. 3 is the smallest dimension, so because it's 3 inches here, think about this, the radius is going to be half of that, or 1.5. It doesn't matter this is 8 inches tall. If you try to take that space up, you're going to end up with this weird oval-shaped object. It's definitely not going to be a sphere, which is a perfect circle. So the way to find this is the radius is actually going to be the smallest dimension divided by 2, which is 1.5 inches. So our radius here for our largest sphere is 1.5 inches. One more here. What is the radius of the largest sphere? Again, radius of the largest sphere that can be cut out of the cylinder below. Well, if you take a look at this, let's draw a circle in here and see what it looks like. I'll try to make it look like a pretty good circle. Let's put this circle in. Oops, I messed up. Let's try this one more time. It's hard to me to get an exact circle. Okay, and I'm going to slide it into place. So if I can get it to slide into place, I can't find the right connector. Here it is. Okay, so if I put my sphere right here, you can see, class, it doesn't matter that it's 20 inches or 20 feet in diameter. This space right here is going to get cut off. We don't need that. The limiting factor to our radius is going to be the smallest dimension. That means our radius here is going to be half of 16, or 8. The rest of this material, just like this material right here, is going to get cut off. And just like this material right here, actually the sphere fits perfect in a cube. Not much material being cut off. Okay, so in this case, we're going to take our radius is going to be the smallest dimension that's going to affect it, divided by 2, because that's going to be diameter, and that's going to be 8 inches. So the largest radius, or the largest sphere we can cut out of this cylinder is going to be 8, well, it's not inches, it's going to be 8 feet, a radius of 8 feet. We'll continue on question number 33 in the next video.